Okay, this is chapter 1 of the pure content. I've split the content into basic and intermediate skills. Basic is what I consider what you need just to get a grade, kind of an E, maybe a D grade, and then intermediate, which is maybe pushing for a C grade. That's about it for this chapter because there's nothing all that difficult, it's mostly GCSE content. In future chapters there'll be an advanced section for people pushing towards a B or an A grade. So I'm just going to run through the content. To begin with, in the basic section, you've got indices, like your index laws from GCSE. So if you want to multiply together two indices with the same base, then you just add the powers together. If you want to divide them, you subtract the powers. A power of a power, you multiply those powers, and then anything to the power of 0 is 1. That shouldn't really need to go through that in any more detail. Hopefully you got that from GCSE. The thing that I would like to point out is this here. It's kind of more tricky because it's being used backwards. So some people get stuck on what to do in questions such as this. So if you had 2 to the power of x plus 1, and then in another term it was just 2 to the power of x, and you wanted to combine those, then this is the way you do it. It's kind of the top law, but backwards. So you can see there's two things that have been added. You can split those. So you've got 2 to the power of x and 2 to the power of 1, and then multiply those together. So you can see that it would simplify this way, but in some situations you'd want to go in the opposite direction and split those up. Because then if you had 2 to the power of x plus 1 plus 2 to the power of x, you could make it so that they're all 2 to the power of x, and combine those to 3 to the power of x. Sorry, 3 times 2 to the power of x. This one, very common in quadratic style solving. So in the next chapter, the quadratics chapter, there's what I've called pseudo-quadratic equations. This is very useful in that situation because you can use this law, where the power over power, you times the powers together. If you can use that backwards. So if you've got x to the power of 2y, you can split that into x to the power of y to the power of 2. So in certain situations, if you've got x to the power of y as one term, and then x to the power of 2y as another term, then you can make x to the power of 2y, x to the power of y squared, and then it's like a quadratic, although it's not quadratic. Other things which are useful are, expanding brackets. This is difference of two squareds. Next chapter, we'll go into this in more detail with those pseudo-quadratic equations. But recognising a difference of two squareds is useful. This is a big problem that I see a lot of people making, and that's the difference between a fractional power and a negative power. So with a fractional power, you're looking at roots. A to the power of a half is the square root of a to the power of a third is the cube root of a. And people get that mixed up with negative powers. The negative just literally means it's a reciprocal. So it's 1 over whatever the power is. So if it's a to the power of minus 2, that's 1 over a to the power of 2. And if it's a to the power of minus a third, that's 1 over a to the power of a third, which would be the cube root of a on the bottom of the fraction. Surds mostly are not much of a problem because you can just use your calculator to do surds. It's those situations where you are not allowed to rely on calculator technology, where a little bit of surd usage is very useful. There's been a few questions recently where they've made it so if you type it into your calculator, it's not going to simplify it into a surd for you, it'll just give you a decimal. So I've seen those recently, so this is basically it for surds, that and rationalising the denominator. But this multiplying two surds together, just multiply them and it's 1 square root, so root a times root b is root ab, and then the division is the same. If we move on to the kind of intermediate skills, we've got this, which is a big problem when it comes to differentiation and integration. Okay, having a polynomial on the top, and then the same on like a term on the bottom that's got x's. A lot of people will just try and differentiate this before doing anything. So what you've got to do before you do any kind of differentiation with this, or even if you just want to simplify this, is if you've only got one term on the bottom, which is in this case you've just got 4x squared on the bottom, that's one term. You can do 2x cubed divided by 4x squared, and then separately 3x to the power 4 divided by 4x squared. So what that would look like is 2 over 4, so a half, and then x cubed divided by x squared. So that's this one. 3 take away 2 is 1. And then for the second term, it's 3x to the power 4 divided by 4x squared. So again, 3 divided by 4, and then x to the 4 divided by x to the 2. And treat that like you would in GCSE, where you do the numbers and each of the letters. Normally it's just the one letter, and you can see it gets more awkward with things like fractions and negatives, but it's the same process. Do this as one term, and then this as a separate term. Now, obviously you can't do that if you've got more than one term on the bottom, but most of the time it's like this. For expanding brackets, it can get a little bit more tricky if you've got, say, a binomial and a trinomial. In this situation, I would probably recommend using like a grid method. For most, you don't have to, but if you've ever used a grid method to expand, it means that you don't miss anything. So dy, I like to put the pluses in, plus e, and then you would fill in each of these boxes with just the product of the column and the row. Okay, and that way you don't miss anything. As if you had 3 by 3 as well, like a trinomial times a trinomial, it's really easy to miss things. So I would use that if you are finding that you're missing things. Next one is factorising a cubic which doesn't have a constant term at the end. So it's just the cubic, the quadratic and the linear term. With that, you can simply take out an x from each, so factorise out an x, and if a, b and c have a common factor, you can do that as well, but most of the time that's unnecessary. And then you've got the x, and then you've got a quadratic that you can solve however you solve quadratics. That's the next term, sorry, the next chapter, but that could be by using the formula, or by just using the calculator, or by factorising further. But taking out that x, what I see a lot of people doing is dividing by x, and that's not okay. You can't just divide by x, because x could be equal to 0, and you're not allowed to divide by 0. So get into the habit of factorising things out rather than dividing by them. This is a big problem for most. This is just like this, but with fractions and negatives. Now, it's no different in terms of the method, but I see a lot of issues because people get confused about what's going on, and it's maybe just that you don't know your index laws very well, or that you just haven't practiced it enough. So with these, you're going to do 2, it's the same as before, like this divided by this as one term, and then the second term is this divided by this. You can split it into 2. So 2 over 4, half, and then it's x to the power of a half divided by x to the power of 4/3. So that is going to be x to the power of a half take away 4/3. You can just use your calculator. Mine's over there, so I'll just try and do it in my head. It's 3 over 6 and 8 over 6. So it's 3 take away 8, which is minus 5 over 6. It's very useful when you're going to then go on to differentiate or integrate. The second term, 5 over 4. And then it's negative 2/3 divided by, well, sorry, x to the negative 2/3 divided by x to the 4/3. So that is negative 2/3 take away 4/3, which is minus 2. Is it? No, it's positive 2/3. So negative 2 minus 4. Oh yeah, minus 2. So check those with your calculator if you are not happy with fractions, as I apparently are. But that's the process. It's this one divided by this one as the first term, and then this one divided by this one as the second term. The last and final one is rationalising the denominator. Very infrequent this comes up because most of the time you'll just put it into the calculator and it would rationalise it for you. But if it ever does come up, it's possible that it would come up if they're just testing your algebra skills early on in the paper. You would multiply by this, but with the opposite sign in the middle. So top and bottom get multiplied by 2 root A minus root B. 2 root A minus root B. And when you do that, it's like difference of 2 squareds in a way. Root B. 2 root A minus root B. I'm not going to do it, but you would expand each of these, and on the bottom you're going to get 2 times root A times root A, so that would be 4A. The 2A, or 2 root A times minus B, and 2 root A times positive B are going to cancel, and then you're going to have positive root B times negative root B, which is minus B. So the bottom at least would be, what did I say, 4A minus B, which is rational, so long as A and B are rational. And that's it for chapter 1. I mean, I understand that was a whistle-stop tour, but those are the skills, the knowledge that you need for chapter 1. As I say, most of that is GCSE, but moving on to the later chapters, it will become more tricky. But if you need to practice those skills, then definitely practice those skills, because the A level is much more algebra heavy than the GCSE was. So if you're making any mistakes on any of these things, sign errors, or when you're expanding things, you're missing stuff, missing terms out, that's just going to lead to you losing lots and lots of marks in most questions. So it's imperative that you get these skills sorted to get the higher marks and the higher grades on A-level maths. Okay, thanks.